Right now, as you watch this, something is consuming an entire star, piece by piece, atom by atom. 42% of that star's mass? Gone. Converted to pure energy, released as plasma beams that could incinerate our solar system from 50,000 light-years away. These aren't Hollywood monsters, they're not alien weapons, they're the universe's most efficient killing machines, and they're sculpting reality itself. Welcome to the truth about black holes, where the laws of physics don't just bend, they shatter, where time stops, space screams, and information itself might die. Buckle up, we're going where light cannot escape. Picture the ultimate cosmic tug-of-war, a star 20 times more massive than our Sun, burning through nuclear fuel like a Ferrari with the gas pedal welded to the floor. For millions of years, it's been fighting, fusion pushing outward, gravity crushing inward. This stellar heavyweight has been living on borrowed time, and gravity is about to collect. When stars this massive, 10 to 20 times our Sun's mass, exhaust their nuclear fuel, there's no gentle fade to black. This is a catastrophic collapse in less than a second. The core implodes so violently that protons and electrons are smashed together. If the star is massive enough, not even neutron degeneracy pressure can stop the collapse. The core keeps shrinking, even past the size of a molecule. Here's where it gets genuinely terrifying. It doesn't stop. The matter collapses to a mathematical point, zero volume, containing the entire mass of multiple suns, infinite density. This is a singularity, where our understanding of physics literally breaks down. But the singularity isn't the black hole, it creates one. As matter collapses, it warps spacetime so severely that it creates a boundary called the event horizon. Think of it as a cosmic waterfall, where space itself is falling faster than light can swim upstream. Cross this line and you're not just doomed, you're erased from the universe's story. The size of this cosmic prison depends on mass. Stellar black holes, dozens of solar masses, might have event horizons just 60 kilometers across. But then there are the supermassive beasts, millions to billions of solar masses lurking at galactic centers. Our own Sagittarius A star weighs 4.3 million suns and could swallow Mercury's entire orbit within its event horizon. Here's the cosmic joke. The most influential objects in the universe are completely invisible. We discovered them through backdoor detection, watching their victims dance. In the 1970s, astronomers noticed something bizarre in Cygnus. A blue supergiant star was orbiting empty space every 5.6 days, while X-rays screamed from the void as stellar material heated to 100 million degrees before vanishing forever. We'd found our first stellar black hole, Cygnus X1. Then came 2019, the year we photographed the unphotographable. The Event Horizon Telescope captured the shadow of M87, a supermassive black hole 6.5 billion times our Sun's mass. The image revealed a golden ring of glowing plasma bent by gravity so extreme it created a perfect Einstein ring, exactly as general relativity predicted. But that was just the beginning of the weirdness. Enter 1ES1927 plus 654. A galaxy that's been breaking the rules since 2018. This changing-look active galactic nucleus underwent something that should be impossible. Its accretion disk vanished, then rebuilt itself while launching a relativistic jet. We watched a cosmic construction project happening at nearly light speed, with X-ray flares and radio emissions spiking by factors of 60. Even stranger, we've detected rogue supermassive black holes, massive gravitational wave signatures appearing nowhere near any known galaxy core. These cosmic wanderers, they drift between galaxies like nomadic destroyers, occasionally revealing themselves through tidal disruption events when they shred passing stars. These discoveries revealed black holes aren't just cosmic vacuum cleaners, they're galactic thermostats. When material falls into a supermassive black hole, up to 42% converts to pure energy through relativistic jets that stretch millions of light years. These plasma beams heat intergalactic gas, either triggering or completely shutting down star formation across entire galactic neighborhoods. It's cosmic climate control. Black holes regulate how galaxies grow, determining stellar birth rates and sculpting galactic evolution. Without this feedback mechanism, galaxies would either burn through all their gas too quickly or never form stars at all. The universe would be a very different, probably lifeless place. This is where black holes become genuinely unsettling, not because they're destructive, but because they expose the fundamental cracks in our understanding of reality. At the singularity, our two most successful theories declare war on each other. General relativity describes gravity and spacetime beautifully, but breaks down when volumes approach zero. Quantum mechanics governs the microscopic world, but can't handle extreme gravitational fields. The result? We literally don't know what happens at the center of a black hole. Then there's the information paradox, which has kept physicists awake at night for decades. Quantum mechanics insists information cannot be destroyed, ever. But black holes? They seemingly delete whatever falls in. This creates a fundamental contradiction that challenges our most basic assumptions about reality. Stephen Hawking threw another wrench into the works in 1974, showing that black holes emit radiation due to quantum effects near the event horizon. Over trillions upon trillions of years, this Hawking radiation will cause black holes to evaporate completely. But here's the mindbender. As a black hole shrinks, it gets hotter. When it finally evaporates, it goes out in a flash more violent than a hydrogen bomb. The evaporation process raises the information paradox again. Where does the information go when a black hole disappears? The answer might require quantum gravity, a completely new theory unifying our understanding of the very large and very small. Some physicists propose black holes are actually holograms, with all their information encoded on their two-dimensional surface. Others suggest they're portals to other universes, or that they transform into white holes, spewing out everything they once consumed. The truth is, we don't know, and that's what makes black holes so compelling. They're cosmic laboratories, testing the limits of human knowledge. And just this year, astronomers made a discovery that rewrites the cosmic timeline. The James Webb Telescope spotted a black hole called LID 568, feeding at 40 times its theoretical limit, the Eddington limit, just 1.5 billion years after the Big Bang. This cosmic glutton is devouring matter so violently, it challenges our understanding of how supermassive black holes grew so massive so quickly in the early universe. Another monster discovered in 2024 has been gorging for 12 billion years, visible at almost the dawn of time. These findings suggest black holes might have been the universe's first architects, growing to billions of solar masses when the cosmos was still a cosmic infant. The discovery could explain why we see so many giant black holes appearing impossibly early in cosmic history. They weren't following the rules we thought governed their growth. The Dark Energy Spectroscopic Instrument uncovered 300 new intermediate black holes plus 2,500 new active black holes in dwarf galaxies. This is revolutionary because intermediate mass black holes, weighing hundreds to thousands of solar masses, have been the missing link in black hole evolution. Most black holes are either lightweight, less than 100 solar masses, or supermassive, over 1 million solar masses, making these intermediate giants the theoretical seeds of supermassive black holes. We also discovered Gaia BH3, a sleeping giant 33 times our Sun's mass, located just 1,926 light-years away in the Aquila constellation, making it the second closest known black hole to Earth. Intriguingly, only 70 of the newly discovered intermediate mass candidates overlap with active galactic nuclei, raising fundamental questions about black hole formation and evolution within galaxies. These discoveries are filling crucial gaps in our understanding of how black holes grow from stellar remnants to galactic monsters. So, there you have it. Shadows in the void that aren't shadows at all, but the universe's most powerful engines of creation and destruction. From stellar death throes to galactic thermostats, from information paradoxes to the fundamental nature of reality itself, black holes are cosmic Rosetta Stones waiting to unlock existence's deepest secrets. They challenge our most basic assumptions. Can information truly be destroyed? Is space-time fundamental or emergent? Do we need a completely new framework to understand the universe at its most extreme scales? Every black hole discovery brings us closer to these answers. But this is just the beginning. Dark matter makes up 85% of all matter, yet we've never directly detected a single particle. The Big Bang created everything from nothing in less time than it takes light to cross a proton, and gravitational waves are giving us an entirely new sense for experiencing the cosmos. If this edge of reality journey fired you up, hit like and subscribe for more universe-busting secrets ahead. We're just getting started on this journey to the edge of everything we think we know.